So today, the standard we're using is we're solving equations by factoring, and the standard that goes along with that talks about equivalent forms of expressions. And we've been doing that. When we were factoring, we've been creating an equivalent form of an expression. And in this case, we're going to use those equivalent forms to solve a quadratic. And so when we finish the lesson today, we'll be able to solve a quadratic by factoring. Well, we've already learned quite a good bit about factoring, so there's nothing really new there. I will mention to you that what we're calling a quadratic has a exponent of 2. If the degree is 2, in other words, the biggest exponent is 2, we call that a quadratic. And that's really important to know. So the examples that we're looking at today, the problems we're looking at today, these are quadratic equations. And really what we're getting at here is, and we'll graph these later, but a quadratic looks like a parabola. So what you're seeing on the screen, that's what we call a parabola. It's kind of a U shape, except it kind of continues to open up. And this is a parabola. We'll talk more about parabolas later, but I think it's important for you to know. One thing about it, our answers, we're going to give lots of different names. The solutions is what we're going to call it today, but later on we'll call it an x-intercept or a root or a 0. Let me show you why. Notice that I've got some parabolas here. This parabola doesn't cross the x-axis, and it would have no solution. But this parabola sits on the x-axis, it would have one solution. And this parabola crosses the x-axis here and there. So that's the 2 solutions. So when we're finding solutions to quadratic equations, then what we're doing is that we are finding the location where that parabola crosses the x-axis. There are several ways to solve them, and so we're going to start out today solving them not graphically, so you don't have to worry about graphing them, but rather we're going to solve them by factoring. So today's date, January 18th, 2021. All right, and you're going to be able to solve quadratics by factoring. So write this first example down, please, okay? This is example 1. X squared minus 8x equals negative 12. Now notice right away that our highest exponent is the x squared. Therefore, it has a power of 2 or is a quadratic. So to solve quadratics, we want to do a couple things. First of all, we want to set the quadratic equal to 0. Well, that isn't really a complicated process. We know how to do that. We know that I want to move this negative 12 to the other side of the equal sign so that it'll be equal to 0, and I'll do that by putting the opposite of negative 12 beside it and by adding 12 to both sides. That's old solving equations. We've been doing that for a long time now. So it's x squared minus 8x plus 12 equals, and now negative 12 plus positive 12 is 0. That's what I want to do. I want to set it equal to 0. So that's step 1. Set the quadratic equation equal to 0. Step 2 then is we want to factor that quadratic equation, or that trinomial in this case. And to do so, we'll find the GCF first. And the GCF likely will be 1, but it could not be. and then we'll factor using all the methods that we've learned. So here's our second step. Let's factor this. Not a hard one to factor because the GCF is 1. Because the coefficient of x squared is 1, that's all it could be. And so x squared then will be x times x. And we're looking for factors of 12 that will add up. I'm using that sign to tell me I want them to add up instead of subtracting. They're going to add to be a negative 8. Well, that means that both factors will have to be negative. 1 times 12 is 12, but when I add add those two together, 1 plus 12, its sum is 13, and I need a negative 8. So I'm going to look at negative factors. Negative 1, negative 12. That gives me a positive 12, but that adds up to be a negative 13, so that's not it. Negative 2, and negative 6, negative 3, and negative 4. All those multiply to be positive 12, and the only one that adds up to be negative 12 is the middle term. Excuse me, it doesn't add up to be negative 12, it adds up to be negative 8. So that's the one I'm looking for. So my factors are x minus 2 and x minus 6, and that equals 0. Well, the third step involves something that I think is a really cool property. It's called the zero product property. And here's what it means. It means if you multiply two things together and you get an answer of 0, one of those two things had to be 0. Or write it mathematically this way, a times b. If a times b equals 0, then either a is equal to 0 or b is equal to 0. Has to be. There's no way you can multiply two numbers together and it equals 0 unless one of those two numbers is 0. So I'm going to use that property, and here's how I use that property. I'm going to multiply x minus 2 times x minus 6. I factored it, okay? So that means I multiplied x minus 2, and I multiplied it times x minus 6, and I got 0. So I'm going to break it into two parts. That means either x minus 2 is equal to 0, or x minus 6 is equal to 0. One of those two has to be equal to 0, and then I'm going to solve those as separate equations. I guess I should write that step down, is to set the factor equal to 0 and then solve. All right, so if I do that, I know automatically x minus 2, when I isolate x, I'll add 2 to both sides. So that means x is equal to positive 2. Or add 6 to both sides here. And of course, I'll get x is equal to positive 6. So my solution has two answers, just like I showed you a minute ago, that it crossed the x-axis in two places. Those are the two places it would cross the x-axis, at 2 and at 6. So my solutions are 2 and 6. And I'm not going to have to worry about the graphing side of it for this lesson, but I will say in set notation, my solution is 2 or 6. Okay, and it can be either one of those. So for most of the problems we have today, we're going to have two answers for. And there'll be two places for you to enter your answer on your homework of the two answers that you've got. So that's all you have to do to solve quadratics. by factoring. So let's look at a second example. And this one is x squared plus 15x equals a negative 54. So our first step to solve quadratics by factoring is to set it equal to 0. So in order to do that, you have to add 54 to both sides. And what I want to have happen is the negative 54 and the positive 54 becomes 0, which it does. And so that leaves me with x squared plus 15x plus 54 equals 0. So my next step is to factor. We'll look at x squared plus 54x. The GCF here is 1. Because x squared has a coefficient of 1, that's going to be the GCF. There's no x on 54. So I'm looking for factors of 54, things that multiply to be 54, but will add to be 15. And so I think about that. That's 1 times 54. I'm only going to consider positive ones because they're going to add to be 15. And 15 itself is positive. Of course, I know that negative 1 times negative 54 equals positive 54, but if I add those two, I get a negative answer. So I'm not going to worry about those. So I got 1 and 54, 2 and 27. If I add 2 and 27, I get 29. That's not what I'm looking for. 54, I believe, will divide by 3. And that's 3 times 18. If I add those two, that's 15. 54 will not divide by 4 evenly, but 6 times 9 is 54. And if I add 6 and 9, I get 15. So it'll be x plus 9 times x plus 6. All right, so using the zero product property, I will set the factors equal to 0. Because remember, either that has to be equal to 0 or that has to be equal to 0. If I multiply the two, it can get 0. All right, so it's x plus 9 equals 0 and x plus 6 equals 0. So subtract 9 from both sides here. X equals negative 9 and x equals negative 6. And those are my answers. So solving a quadratic by factoring is pretty easy. Well, let's look at a third example. This time, the factoring is going to use a little different method because I'm actually going to have a coefficient of x squared that's greater than 1. So this one is 2x squared plus 7x minus 2 equals 4x squared plus 4. Now remember, step 1 is to set everything equal to 0. Well, in order to do that, I need to subtract 4x squared from both sides. And actually, I need to also subtract 4. So we'll kind of do that in one step. These will cancel out, and those will cancel out, which sets it equal to 0. 2x squared minus 4x squared is negative 2x squared. Bring down the plus 7x. Negative 2 minus 4 is a negative 6. And those all canceled out, so that's set equal to 0. Now, if I looked for a GCF, 2 won't divide 6, or excuse me, 2 won't divide 7, it will divide 6. So my GCF is going to be 1, but remember, we don't factor with a leading negative. So my GCF actually is going to be -1. I'm going to factor out a -1 all the way through. So I'll be left with 2x squared plus 7x. Make that -7x, excuse me. Forgot to reverse my sign there because negative times negative is positive. And then plus 6. So effectively, all my signs reverse when I factor out that -1. Got to be careful to make sure I reverse all my signs. So now it's to the next step, which is to factor. And remember, when I have a coefficient larger than 1 of x squared, then I'm going to use that slide and divide method. So I'm left with x squared minus 7x plus 12 equals 0. So I'm looking for factors of 12 that will, okay, this time they're going to add up. The two factors are going to add, but they're going to add up to be a -7, meaning both factors have to be negative. You know, factors of 12 are 1 times 12. But if I add those up, I get a 13, so that's not going to work, okay? So I need all, and it's positive 13, so I need all negative factors. So a -1 times a -12, that'll give me a positive 12, add them up, I get -13. How about a -2, -6, when I add those up, I get -8. And then a -3 and a -4. Multiply those together, I get positive 12, but if I add them, I get -7. That's what I'm looking for. So if factors to be x minus 3 and x minus 4, but remember, initially I'm multiplied by 2, so I've got to go through here, and I've got to divide each of those second terms by 2. All right, so I've got a -1, and I've got, I can simplify x minus 3 over 2 by multiplying through by 2. So this will be 2x minus 3 here, and x minus 4 divided by 2 is 2 there, and that equals 0. A stray 12 there. So I'm going to take each factor now. I can set 1, but 1 will never equal 0, so I don't have to worry about that. I've got 2x minus 3 as a factor, and I'm going to set it equal to 0. And x minus 2 is a factor, and I'll set it equal to 0 as well. All right, so let's solve each one of these. Add 3 to both sides. I get 2x is equal to positive 3 divided by 2 on both sides. And I'm going to leave that fraction as an improper fraction. So x can be 3 over 2, or x could be equal to positive 2. So those are my two answers. In this example, we're going to use a quadratic equation to solve a problem. The problem is kind of an interesting problem, really. In this problem, what we're going to do is we're going to solve the problem of a baseball player hitting a baseball in the air and figuring out how long it's going to take to hit the ground. Well, there is a quadratic equation that will model the path of any object, any projectile. And that quadratic equation is this: h equals -16t squared plus vt plus s. Now let me define a few parts of this. In fact, you'll see this in Algebra 2. You'll continue to see it in Algebra 1. This particular equation didn't go anywhere at all. So you're going to see it for quite a while. First of all, h represents the height of the projectile. V is the initial velocity. And S is the starting height. Of course, T represents time. So here's the question. A baseball player hits the baseball into the air. How long will it take to hit the ground? So we need some information, a little more information. The ball is hit at 3 feet above the ground. It has a upward velocity, meaning it's positive. If it had a downward velocity, it'd be negative. 47 feet per second. Okay. And we're wanting to know how long will it take to hit the ground? Well, the ground would have a height of 0 because that's where we start off. So let's see if we've got some of these variables in here. First of all, if the ball is hit at 3 feet above the ground, that's the starting height. So S is equal to 3. Upward velocity of 47 feet per second. So my V velocity is 47 feet per second. And we're wanting to know when is it that H is equal to 0. So if that's the case, we're going to solve for T. We want to know the time. So when is it that that it hits the ground? How many seconds does that amount to? So that's what we're looking for. Let's take all those values we found and plug into this equation I gave you to start out with. It models the path of the ball. So we want to know when is it that H is 0. So the first part of that is 0. So we'll plug a 0 in for H. And I know it's going to be equal to negative 16. Now, I don't know the time. That's what I'm looking for. Is how long does it take till it gets to 0? So I'm just going to leave T squared in there, just like I've got here. Plus, now I said the velocity is 47, so it's 47 T. And my starting height is 3, so I'll plug a 3 in for S. So all I did so far, nothing magical or complicated. I just plugged in the variables I found here into that quadratic equation. So all it's left to do now is just to focus in on that quadratic equation and solve it. I could write it a little differently. I could write it this way. I could write it negative 16t squared plus 47t plus 3 equals 0. I like that better because it's what I've been doing each time. I want to know, is there a GCF? I know it's going to be a negative 1 at least because I've got a leading negative. And then I guess I really need to know, will 16 divide by 3? Well, no, it won't, will it? All right, so my GCF is negative 1. So I'm going to factor that out. It's negative 1 times 16t squared plus 40. So make that minus 40. So I got to reverse all my signs. And minus 3. So let me make sure I did that right. This negative becomes positive. This positive becomes negative. Okay, good. And that positive becomes negative. So I've done that. I factor out that negative 1 like I need to. I'll multiply 16 times negative 3 to factor it. So this will be t squared minus 47t minus, I believe 16 times 3 is 48. You should double check me on that. And so I'm looking for factors of negative 48 that will subtract to be negative 47. And that means because I'm going to multiply two things together and get a negative, that one will be negative, the other will be positive. Actually, this one's going to be pretty easy because a negative 48 times a positive 1 gives me negative 48. But if I add negative 48 and 1, I get negative 47. So there's a set of factors I'm looking for. So I'm going to rewrite it as negative 1 times t minus 48. Remember, I multiplied by 16, so I've got to divide by 16. And t plus 1 divided by 16, and those equals 0. Well, one more step to simplify things out. 48 divided by 16 is 3. So this would be t minus 3. And to simplify that one, that's going to be 16t plus 1. Not going to set negative 1 equal to 0 because that's not a negative 1 never equals 0. So we just throw that one out. T minus 3, I can set that equal to 0. So t will be equal to positive 3 there. And then the last one is 16t plus 1 equals 0. So I subtract 1 from both sides. I get 16t equals a negative 1. Divide by 16, I get t is equal to negative 1/16. Wait a minute. I'm talking about time here. I want to know how long it's going to take the ball to hit the ground, and it's never negative, so this is an extraneous solution. We don't have to worry about that. So the answer is positive 3. So it will take 3 seconds for the ball to have a height of 0 or to hit the ground. Wow, not such a complicated problem after all. So again, all I have to do is use the quadratic equation and factor that quadratic equation, setting each of the factors equal to 0, and I can solve quadratic equations by that method. And there's several other methods we'll be looking at, but today I can do it by factoring.